Hello everyone, myself Trisha, third year computer science student. I am going to present about support vector machine in this video. Here we will have an overview of the types of support vector machine, hyperplanes and support vectors, and pros and cons of support vector machine. First of all, we'll discuss about what is support vector machine. Support vector machine is a powerful supervised algorithm that works best on smaller datasets but on complex ones. Support vector machine, abbreviated as SVM, can be used for both regression and classification tasks, but generally they work best in classification problems. They were very famous around the time they were created during the 1990s and keep on being the go-to method for a high-performing algorithm with a little tuning. It is a supervised machine learning problem where we try to find a hyperplane that best separates the two classes, whereas support vector machine is based on statistical approaches. Next, we'll discuss the types of SVM. There are two types of SVM. One is linear SVM and the other one is nonlinear SVM. Linear support vector machine. When the data is perfectly linearly separable, only then we can use linear SVM. Perfectly linearly separable means that the data points can be classified into two classes by using a straight line, if 2D. Then such data is termed as linearly separable data, and classifier is also called as linear SVM classifier. So as it is 2D space, so by just using a straight line we can easily separate these two classes, but there can be multiple lines that can separate these classes. Non-linear SVM. When the data is not linearly separable, then we can use non-linear SVM, which means when the data points cannot be separated into two classes by using a straight line, then we use some advanced techniques like kernel tricks to classify them. In most real-world applications, we do not find linearly separable data points, hence we use kernel trick to solve them. What is hyperplanes and support vectors? Hyperplane. There can be multiple lines or decision boundaries to segregate the classes in n-dimensional space, but we need to find out the best decision boundary that helps to classify the data points. This best boundary is known as the hyperplane of SVM. To classify these points, we can have many decision boundaries, but the question is which is the best and how do we find it? Since we are plotting the data points in a two-dimensional graph, we call this decision boundary a straight line. But if we have more dimensions, we call this decision boundary a hyperplane. The dimensions of the hyperplane depend on the features present in the dataset, which means if there are two features, then hyperplane will be a straight line, and if there are three features, then hyperplane will be a two-dimension plane. The best hyperplane is that plane that has the maximum distance from both the classes, and this is the main aim of SVM. This is done by finding different hyperplanes which classify the labels in the best way, then it will choose the one which is farthest from the data points or the one which has the maximum margin. Support vectors. These are the points that are closest to the hyperplane. A separating line will be defined with the help of these data points. The advantages of using SVM are it is effective in high dimensional cases, its memory is efficient as it uses a subset of training points in the decision function called support vectors. Different kernel functions can be specified for the decision functions, and it's possible to specify custom kernels. And the disadvantages are it is unsuitable to large datasets, more features and more complexities, bad performance on high noise, and does not determine local optima. Hereby, I conclude with the summary that support vector machine is a powerful machine learning algorithm used for classification and regression analysis. It works by finding the best hyperplane that separates the data points into different classes. Linear SPM is used when the data is linearly separable, which nonlinear SPM is used when the data is not linearly separable. SPM has several advantages over other machine learning algorithms and is widely used in various fields. I hope this video is useful in knowing about support vector machine. Thank you.